Hi everyone, in this video we are going to practice performing calculations that are going to allow for us to calculate or convert between energy and frequency, or maybe even energy and wavelength. But basically what we're going to do is try to find a way to convert between energy, wavelength, and frequency, and we're going to practice it here in this video. Alright, so the first question we have is that high energy UV radiation can cause skin cancer. So what is the energy of a 280 nanometer wave? Go. Alright, did you get an answer? Hopefully you did, but if you didn't, that's okay. The first thing you need to do is start identifying your variables, okay? So now when we're doing energy calculations, they're just a little bit more complicated than just wavelength frequency calculations, so it's very important that you identify the variables as the very first step. So we're saying that we have a 200 nanometer wave, so right away we know our wavelength is 280 nanometers. Now, right away you should be saying, I can't have nanometers, so I need to convert. And so we know that there's 1 times 10 to the 9th nanometers in every 1 meter. So if we were to calculate this out properly, we would say that we have a wavelength of 2.8 times 10 to the negative 7 meters. Okay, so that's our wavelength. We also know that we have a very easy conversion to go between energy and wavelength. So we just have to use that simple formula of E is equal to hc all over lambda. Now, H is Planck's constant. That never changes, so let's remind ourselves of that one. That is 6.626 times 10 to the negative 34th, and that's a joule second. And then speed of light's never going to change, 3 times 10 to the 8th meters per second. Now all we have to do is plug it into this formula. So energy is equal to Planck's constant, 6.626 times 10 to the negative 34th joules second, times the speed of light, which is 3 times 10 to the 8th, and that's in meters per second, all over our wavelength, which we previously calculated to be 2.8 times 10 to the negative 7 meters. If you plug this into your calculator properly, you end up with an energy equal to 7.09 times 10 to the negative 19 joules. Okay, that's how you should do that problem. If that doesn't make sense, pause for a second and go back through it and make sure you can do that again. Otherwise, let's go ahead and move forward. This time, we're going to give you a term for energy, 6.1 times 10 to the negative 30 joules. Now I want you to back calculate and determine what that means in terms of its frequency. Go. Alright, did you get an answer? Hopefully you did. Just like before, we have to identify our variables. So we know that it has an energy of 6.1 times 10 to the negative 30 joules, because it says that it contains this much energy, and we know that we're trying to determine our frequency. So we just can use an even simpler equation than we did in our previous problem, where E is equal to h nu. H is Planck's constant, that's not going to change, and so all we have to do is plug in our other values. So our energy was given to us, 6.1 times 10 to the negative 30 joules. Joules is absolutely the perfect unit for this. Planck's constant is at 6.626 times 10 to the negative 34th joules per second. Now this is something that would always be given to you, but you may start to realize that very quickly you're going to memorize this because you're going to do so many calculations and practice problems with this that you might just memorize it, but that's okay. But it will always be given to you. Otherwise, then you just plug in your frequency. Now you just do a simple math problem of 6.1 times 10 to the negative 30th divided by 6.626 times 10 to the negative 34th. And you end up with a frequency equal to 9,206.2 inverse seconds, or we can call that hertz, whatever you want. All right. Hopefully that's making sense. This is really fairly straightforward. It's just plug and chug. You need to be able to determine what is a frequency, energy, or wavelength based off a word problem, but that's really as hard as it gets, because then you just need to be able to use those two formulas. All right, so now I'm going to turn it on its head, and we're going to go back to Planet Dwarf, where all things have changed. We're on a new universe, new planet, and now we have some more information. We've changed the speed of light. The new speed of light is now 7.2 times 10 to the 12th meters per second, same term as we used in that previous practice video. But now what we're going to do here is see if we can figure out what our wavelength is, given that it has a very specific energy of 1.546 times 10 to the negative 10th joules. Go. All right, did you get an answer? Hopefully you did. The first thing you have to do is identify your variables. So the first thing I do here whenever we're on a new universe is I very quickly identify any of my constants that have changed. So in this example, we now have a new speed of light. So that is now C. I just do prime because that helps me. C prime is equal to 7.2 times 10 to the 12th meters per second. Now we also have been given a value for energy. So we're saying that energy is 1.546 times 10 to the negative 10th joules. So we have a speed of light, we have an energy. We're we're looking for wavelength. So really all we have to do is E is equal to hc all over lambda and solve for lambda. So our energy was given to us, that's our 1.546 times 10 to the negative 10th joules, appropriate unit, that's good. Planck's constant hasn't changed, 6.626 times 10 to the negative 34th joules times seconds. Then your speed of light, this is the new speed of light, so I'm going to actually go ahead and put C prime there so there's no confusion. We have 7.2 times 10 to the 12th meters per second. Alright, so now we're solving for our wavelength, so we just divide by wavelength. Really all you have to do is put this in your calculator, so Planck's constant times 10 new speed of light divided by your energy that was given to us, and we get a wavelength. If you do this properly, you get something that is 3 times 10 to the negative 11th meters, or if you want to do something in a more familiar unit, that's about 0.03 nanometers, so something that's really, really small, okay? So hopefully this is something that makes sense. Obviously, going to a new planet or a new universe tends to kind of make things a little bit more complicated, but if you can answer problems when you're on a new universe or you have new rules, that means that you actually understand this material and you thoroughly get what's going on in this course, which makes me super, super happy. So hopefully this is going okay. If not, please stop, do more problems. You just want to practice this as much as you can until this is super easy for you. Have a great week, take care of yourself, and drink water.